Hey everyone, I'm Swati and welcome back to our series of mechanics. Today's video is all about addition and subtraction of vectors, in which we deal with directions and angles and everything. This video is also very simple and we'll do numericals. So let's begin with that. Okay, so before we start with addition subtraction, let's first understand the angle between two vectors. Yesterday, in our last video, I have told you that the vector is denoted by this. Okay, so this is its tail and this its head. Okay, so now for the angle between them, between two vectors, their tail should meet, and whatever the angle between them is the angle. Okay, so for example, if one vector is this A vector, okay, and B vector is this, and the angle between them is 45 degree, so the angle is 45 degree. But if let's say one is this, other is this, so now the tail and head are meeting and angle is like 150 degree. So what you have to do, you have to meet this tail, so you have to extend this to like there. Okay, so the angle between them will become 30 degree because it becomes linear. So 150 plus 30 is 180. So now the tail and tail of both the vectors are in contact. So the angle between them is 30 degree. Okay. And let's say if this is this and this is this, and the angle between them, let's say again, is 150 degree. So now this vector has to be transported or to here like this something, or you can shift it to somewhere here, and angle between them will become 30 degree. Let's take this vector and move it to here. Okay, now the tails are in contact, so angle is 150 degree. So you have to meet the tail, okay, of both the vectors. Then it would be the angle between two vectors. Okay, so the first thing is this, and the second thing is sometimes it's given in the question like 30 degree south of west, or you can say west of south. वेस्ट ऑफ साउथ, तो दिस इज साउथ से वेस्ट की तरफ, साउथ से. सो इफ यू मेक दिस नॉर्थ साउथ ईस्ट वेस्ट कार्टेशियन प्लेन, नॉर्थ साउथ east west, so it is 30 degree west of south. So then it means like this 30 degree. If it is something like 60 degree north of east, here east of north, let's say east of north, then it should be between east and north, and from north to east it's 60 degree. Okay, so whatever the direction, the angle comes from that direction. Okay, so this is the angle between the two vectors. Okay, now we'll see how we do addition and subtraction in vectors. What is the vector algebra? Okay, so next is addition of vectors. Okay, if you have to do simple addition, let's say you have a jar, you put 3 liters of water, then you put 1 liter of water, then it is simply 3 plus 1 is equals to 4 liter. Or you have a box, you put 20 kgs of mass, then you put 30 kgs of mass, then it's simply 20 plus 30, that is 50 kgs of mass. Okay, that is simple algebra. But in vectors, what happened? The angle is also involved. Let's say you have a vector A, this, and also you have a vector B, this. So what you will get, another vector, but in some other direction. Okay, so this is a vector this is a vector having magnitude of this A vector plus B vector and in some direction and in some other direction. In other direction, that means not in direction of A and B. Not in the direction of A vector or B vector. Sometime it could be, sometime it's not. So it depends. How it depends, we'll understand. So first thing is, for the addition of two vector, there are basically three rules, three laws. First is triangular law of vector addition. Okay. Second is parallelogram of vector addition. It depends on how the vectors are arranged. Parallelogram law of vector addition. And third is polygon law. Polygon law is a generalized one. This is the generalized one. Okay. So first, if we go for triangular law, so what it suggests, suppose you have a vector, this A vector, another vector is this B vector. Okay, its statement suggests that if the head of one vector joins the tail of another vector, then the resultant of two vector is such that it comes in the opposite direction of the enclosing side of a triangle, forming the resultant of A and B. So if two vectors A and B are such that the two sides of a triangle joining head and tail, then the third side or the enclosing side would be the resultant of these two vectors coming in the opposite sense. Means if these two are going like this, so the resultant would come to this, and that resultant would be A vector plus B vector. You can pause and you can write the statement. If two vectors are considered as the two sides of a triangle taken in the same side, then the third side would be the resultant of these two vectors taken in the opposite direction. Or you can take like if A vector is this, let's say B vector is this, you have to just consider the sides. B vector is this, then the enclosing side would be the resultant vector of A plus B. So you have to only understand the two sides in same direction, then the opposite one would be the resultant. I hope. So the resultant is your A vector plus B vector, where A and B are considered as the two sides of a triangle taken in the same order. Then the resultant is the third side taken in the opposite order. Simple statement. So this is your triangular law. And the second is your parallelogram law. Parallelogram law. This law states if two vectors are taken as two sides of a parallelogram, like this is A vector or this is B vector, and the tail and tail are joined together. Here the tail of one vector and the head of another vectors are joined together. So if tails of both the vectors are joined together, or you can say if two vectors are considered as the two sides of a parallelogram, then the diagonal is considered as the resultant, like A vector plus B vector. And obviously this is also B vector. This is also A vector. Okay, so the diagonal gives you what? The resultant of these two vectors. Okay. For example, this is let's say a mass, a block. A person is moving it with F1 force, another is moving with this F2 force. So where is the resultant, the net force? Will that box move this direction? No. Will it move in that direction? No. The box will move in this direction, which is its resultant, F1 plus F2. So it is diagonal. Okay. So you have learned two things here, that if your head and tail are joined, then the third side in opposite direction gives you resultant. If both the tails are joined, then the diagonal will give you the direction. It would never be like this. Okay, if it is like this, then the resultant would go here, opposite ends, because you can make it forward like this, you can make forward like this, then tail, and the resultant would be like this. Okay, so this is the direction of resultant. And the next is polygon law, and then we'll move to what? Subtraction. So if there are more vectors, more than 2, 3, 4 there are 3, 4, 5 vectors, then what you will do, for example, let's say one vector is here, a vector, then you have this b vector, and all are connected with tail and head. Let's make it a little less. Let's say this is a vector, this is b vector, this is c vector, this is b vector. So you can break it in different triangles. Let's take first this triangle. So this is a plus b vector. Let's say this is r vector. Okay, then you make this third side of this triangle. And this is becoming messy. Wait, let's make it more clear. Okay, so let's say this is your a vector. Okay, this is another vector, that is b. This is another vector, c vector. This is another vector, d vector. So what you will do first, you will take this diagonal, okay, this side from this opposite, and this is your a plus b vector. Okay, now you can take this vector and this vector and this triangle. So this vector and this vector are same, so this would be resultant. If this is your r vector, then this will become r vector plus the c vector, and now r is a plus b, then it automatically becomes a plus b vector. Now this vector and this vector again make sides, so you can enclose it with the third side in opposite order, and then it will become a plus b plus c plus d vector. So if they're in same order, then you can simply add it, and if one reverses direction, you can subtract it. That we will learn in this video. Okay, so this is how you can add the vectors, and what if they flip their sides, we will understand. Okay, now they follow two laws. Okay, they follow two rules. First is commutative rule. For example, if you adding a plus b vector will give you b plus a vector, it is same, nothing to do with the order. For example, you can look at it as parallelogram law. Let this is a vector, this is b vector, so this gives you a plus b vector. Now if you see that if this is b vector and this is a vector, then the diagonal again gives you what? B plus a vector. B vector plus a vector. So the order will remain same. Next is associative rule. That is, you can simply add these two vectors a plus b, then add the c vector, or you can first add b plus c vectors and then c vector. It remains same. So you can understand this as like this is A vector. Let's say this is B vector and this is C vector. So how you will do? You will first take these two vectors, A plus B vector, and then this vector. So this is your A plus B plus C vector. Or you can this is C vector. Okay. So first what you can do, you can take this vector. So this is B plus C in same order. So this resultant will give you B plus C vector. Okay. And now you can take this triangle, this in this order, and this is in opposite direction. So this will be A plus B plus C. So it will remain same. Okay. So this is associative rule and other is commutative rule. Okay. Now we can understand subtraction. Okay. So the next is subtraction of a vector. Subtraction of a vector, and literal meaning subtraction of vector has nothing to do with subtraction. It is basically the negative of a vector, which is its opposite direction, the reversal of a direction. Like we have learned here in triangular law, that is A vector, this is B vector, and this gives me a resultant vector of A plus B. Now if you reverse its sign, that means this is A vector and you are taking B as this in opposite direction, then it becomes minus B vector, and the resultant would be A vector minus B vector. So it is like this. Okay. And for example, let's say this is your A vector, this is the B vector, and this is your resultant vector, let's say C, which is A plus B. Now if you reverse its direction, like let's take it as this, then it become minus C vector. Okay. So for three enclosed side, A vector plus B vector, and here it is C vector, you can say that A vector plus B vector gives you minus C vector, and if you transfer it to here, it becomes plus C vector, that is a null vector. So three enclosed vector in same direction gives you a zero vector. So this is also very interesting. So subtraction and this is in vector literal means the opposite direction of vector, the reversal of direction of vector. Okay. Next, we can understand some of the numericals. So we can develop our concept more. Okay, so let's do first question. Let's consider an object A that runs towards north. Towards north with a ball in his hand, and then it passes the ball to object B, which moves or runs towards south of east. South of east to same distance. Okay. So if these two vectors are considered, then what is the resultant? So for that, basically, this is A, let's say this is the origin, north, and here is south, here is east, and there is west. Okay. So if A runs like this, if A runs here towards north, and then B some south of east, so somewhere here. Okay, this is B vector. Now if you have to find the resultant, so what is the resultant? It could be like this, or it could be like this, or it could be like this. Okay, or it could be like this. So the correct one is, if your vector first A move towards like this is A vector from the origin, and then B moves like this, so they are taken in same order, so the resultant would be from the tip of the first and join the head of the other in opposite sense. So this would be your result. Okay, remember that. Okay, the next question is, let's say if you have a vector something like this. This is A vector, this is your B vector, and this is your C vector. Okay, all in same direction. Then something like this gives you resultant. Wait, let's make a C vector little. So this gives you what? Resultant vector. Now if you have to calculate this resultant as A vector plus B vector minus C vector. So what you have to do? Basically, this is joined. Okay, remember that. So A vector is positive, so it will remain same. B vector is positive, it will remain same. But C vector is in opposite direction. So it should be like this, and this will give you the resultant. Okay. So C will come in the opposite sense. Now if you have to calculate that A vector minus B vector minus C vector, then you have to reverse the direction of B as well. So A will remain here only, A vector, but B will like this, opposite. And if it is plus C, then you can move like this, as it has direction in the quotient, but it is minus C. So what you will do? You will take it to the opposite sense, and this gives you resultant. So that is the minus. Just you have to reverse the direction of the vector. Okay, let's take another question. Suppose you have A vector, B vector, and C vector of equal magnitude, 100, 100, 100. But A is like 30 degree north of east. This is 60 degree south of west, and this is 60 degree east of north. Okay, and you have told that which vector are equal. Which two vectors are equal? Please forgive me for my writing. It is little, but understandable. Okay, so if you say A vector, let's make this plain. If you say A vector, then it is north of east. So this is north, south, east, and west. So north of east. So this is magnitude is same, it's 100 meter. North of east. So it is like this, 30 degree. This is your A vector. Now if you have to calculate B vector, it is south of west. So you have to make it here, south or west. So from west to south, it is 60 degree. And for vector C, it is 100 meter east of north. So this is here only, C vector also here, and it is north of east. North of east is 60 degree. So now if it is 60 degree, then from here it is obviously 30 degree, because north and east makes 90 degree. So yeah, A and C are equal vectors. So the direction from here at 60 degree or from the base, angle from vertical or angle from horizontal, you have to check that. Okay, that makes the difference, and it makes the vectors equal. Okay, the next important thing is, suppose the two vectors A vector and B vector are in same direction. Okay, so where would be your resultant vector? Obviously in the same direction of A and B, like this. Okay, and if one is here, other comes there, then you have to simply subtract it, and the resultant would be in the larger magnitude. If A is bigger, then C would be in the direction of A, because A has larger magnitude. Fine. For example, let's take a question in which you have this F1 force to be 200 Newton. Okay, and the second force is added to it. Some second force is added to it, I don't know, but the resultant would be my 400 Newton. Now, what would be this F2? The first is if F1 is there and F2 is also there, then the resultant force is basically the sum of both F1 plus F2. Okay, so if this is 200, then this could also be 200, and if resultant would be 400 Newton. Another is, let's see, because they don't have give the direction. Okay, they have just given the magnitude. So is F1 is 200 Newton, so you can take F2 as 600 Newton, but in opposite direction. So here you can subtract it. And what happened? F1 minus F2, and the direction would be in F2 because F2 is larger, 600. And if you can subtract it, it again gives you 200 Newton. Okay, so this is in F1 and F2 direction, F1 and F2 direction, and this 400 Newton is F2 direction. Okay, so this is an interesting part, and you can also take one more example. Let's take, this is your F1 force, which is 15 Newton east, along east, and then you have F2 10 Newton along east, then you have F3 which is 40 Newton due west, and then you have this F4 which is 30 Newton again along west, and you have to calculate the maximum and minimum. So if you have to get the F max, then you have to add it. What you will do, you have to take the same direction. Okay, now this 50 plus 10 gives you 60, and then 40 plus 30 gives you 70. Though it is 70 along west, and you have to calculate the minimum force, and you have to take the opposite sign, east west. So if you take that first and third, 50 minus 40 gives you 10, and if you take second and fourth, then 10 and 30 gives you 20. So it is basically 50 minus 40, which is 10 Newton, and 50 is larger. Okay, so it is along east side. Okay, so this is how you can plus and minus the thing. So this is the addition, subtraction, some of the numericals. So in the next video, we will learn the analytical method of this addition, subtraction, which will get the resultant, and we'll work on the numbers and the angles, and we'll do many numericals in the next video. That is tomorrow. So thank you for watching this video, and do like, share, and subscribe, and stay tuned with me for more such videos.